down and I push it up against the indicator. So that looks like it might be, oops, that's not good. If I tightened it in, it would help. Hey guys, welcome back to the shop. So what we're going to do today is I finished up a video on edge finding. I'm using some different indicator styles and methods that we use down here at the shop. I hope that was helpful for you. I figure since I had all these indicators out in one location, I probably should just continue on doing a video on finding holes and bosses and things like that. Because one thing I didn't show you in the last video was the actual coax. And the coax, again, I think is a very valuable indicating tool. I just personally wouldn't use it for edge finding, and that whole other video was about edge finding. So what I'd like to do is I have a piece of material, an old plate from another job set up in the track machine, and I'm going to run through some of the different indicating styles that we showed in the last video. So I'm not going to explain them all over again, so look at that last video if you want to see how we actually use them. I just want to show you how to use a standard bar style pivoting indicator with a standard tip on it, and then the 3D, I call it the 3D indicator, for finding holes, and you'll see how easy that is. And then using the 90 degree or the horizontal style indicator where the head is tilted up. And the contrast between that and this are really the big difference there. So I just wanted to do a quick video on that because, again, since I already had everything set up and we already had all these indicators out, I figured I'd just do that so we can just start moving on to other projects. So again, I'm going to do it in the track machine today only because the Haas, sometimes it's hard to get the camera set up, and the only reason I did the other one in the Haas was because we wanted to show the probing system, and the probing system is exclusive to the Haas right now. In our shop, we don't have one on any other machines. So the track is a little easier, the sound's a little better because it's not in an enclosure. So I'm going to move the camera over to the track machine, and then I have a plate in there, and then we'll go through some of these different indicator styles and show you what the differences are. Okay guys, so we're at the track machine now, and this is a hydraulic cylinder backing plate that we made a while ago, and this would just have to be a scrap one. So this is a good one to show some of the different ways we're going to actually indicate some of these features in. What I have in here first, because I didn't show it in the last video, was the coax. And again, the coax has a couple different tips here. So like this straight tip here, this would be used for doing inside of holes, and the coax comes with a lot of different lengths. So this is a short one. This is an extremely long one. If you can see the whole thing, it's a hypodermic needle, it's so long. And again, because you can get a lot of reach out of these coaxes, which is what's nice about them. And it's the same thing with the internals for doing bores like this outside of this boss here. You have ones that have a little kink to them, if you will, a little angle, and that's for going around the outside of these. And I'll show you how that's done as well. And again, those come in different lengths, so you can get to, you know, really big, long, like really large diameter style indicating. And again, it works really well. The first thing we're going to do is I'm just going to indicate this hole in just to show you. Right now, I don't know where this indicator is relative to this bore. And because, remember on the last video, because there's so much travel available in these coaxes, you don't have to be really close to the center line of these to get these to actually start picking up and actually start working with them. So I'm going to leave it wherever it is. We're going to come down and then see how far we're off, and then we'll start indicating this part in. So I'm just going to start with this small tip on the shallow or the short tip here, because I'm pretty close to the part. So, and there's a little flat on here, and basically the flat goes in up against the locating screw here, and then this is your locating tip here. And this end, just like a regular indicator, you know, you can move it against its little friction component to actually move it to where you want it. So we're just going to bring it down, and then we're going to indicate or start getting some reading on the dial and see what happens. And again, I don't know where we're at here, so I can right now just take a swing around, and you can see I'm pretty far out. You can see how far the indicator runs out away from the circle here and here. I'm actually going to get it a little closer than that, only because That's really far out. So, so right there you can see that the indicator tip is not moving, you know, it's not very centered in the hole. Hopefully you can see that. So what I'm going to do is, I'm just going to go to the, what I think is the furthest point, and I'm going to turn the, remember the nice thing about the coax is that the actual body with the bezel actually moves independent of the actual indicating tip, which is nice because again, then you can keep it in front of you while you're indicating. So what I'm going to do, I'm just going to move this against its friction wheel just to get it past the outside wall here, or inside wall, so I can actually push it in and get some preload on it. And again, yeah, I think that'll work out well. Okay, so let's do that. So I'm gonna, now that I've got it outside this wall here all the way around, I'm actually gonna put it inside the part now. Lock it down. And then what you're going to see is, now we're just going to watch. Now I'm just going to zero this out. And what I tell people when I teach them down here at the shop, engineers and that come down, I'm just chasing zeros. All I'm doing. I could care less about all these other numbers right now. I'm just going to a zero position. And I wish this dial didn't even have all these little numbers on there. I just wish it had one big indication, like a 0 or an A or a B or something, that you just keep going back to. But again, I just say, chase your zero around. So I'm going to watch this, and I usually start front to back and then side to side. It's just a preference. So now what I'm going to do is I'm going to watch this go around, and when I get to the back side, you can see how much travel that actually went around, like 120 thou or something like that. And I still have a lot more available to it. Again, you get a lot of flexibility out of these. So now that the dial went up this way, I'm just going to start bringing it back in the opposite direction. And it's usually half the distance. When the swing's that big, I usually just start picking arbitrary numbers and just try to get it close. So I'm going to go to 0 again, and then, oops, let me get my hand out of the way. So there's the front of my part. Let me start it there so you can see it. And then when I swing it back around to the back side of my part, okay, now we're only, what, 10, 20, or 5, 10, 15 thou out. So I'm just going to come back 7 in the opposite direction. 0 it out there. Come back to the front. That's pretty close. So now that I got the front and back pretty close, I'm just going to go to the sides now. The X component, do the same thing. Put it in 0. Rotate it around. That's only by 5 thou, so let's move it. And again, the nice part about this is that you don't have a mirror, you don't need anything else. Your dial always stays in front of you. And again, that's one of the most convenient things of these indicators, or of these coaxes. And when I'm using the small arm, I rely on the accuracy pretty highly. I think it's pretty accurate with the small arms. When you get the real long arms in there, the ones that have a lot of projection, it's not typically, but I see a lot more deflection of the arm as you're rotating the coax around, so I don't rely on it as heavily. If I really need accurate numbers, I'll get it close with the coax on real big diameters, and then I'll put a regular indicator on an arm in there and dial it in a little more if I need it. But again, this works really well. So you can see right now we're running out a couple thou. So again, I'll just go here, make an adjustment, half of it. So I mean, that's not bad. And I am running on a wiper seal right now, but again, it gives you the idea of how the coax works. Again, the body stays in line with you, which is really nice, and you get a tremendous amount of travel out of the coax. So your part does not have to be that indicated in and that close to center when you're using the coax. So I'm going to switch from the coax now. I'm going to switch the arm to the outside arm for a boss. Pretty much the same process, but I might as well show it since I have it in there. Okay guys, so here's the little, I'm just going to use the smallest implement for the coax. I think it'll be enough to get around this boss, just so you can see what I'm doing. So again, it has a flat on there, which just lines up with the locking screw. So we'll tighten that in here. Now, this is already indicated in from finding the last hole. So we should be pretty close to the outside of this. I did move it around a little bit, but let's just see where we're at, and you'll see how this indicator works. So again, face the dial towards you. What I'm going to do is I'm just going to bring this down, and against the friction component, I'm just going to move it out so I'm outside. Oops. I'm outside the boss, but I'm still going to get some preload when I bring it down and I push it up again. So I'm going to bring this down. And I'm getting some indicator movement, but I want more indicator movement than that. If I was on a regular indicator, I would use that little bit of indication because I know I don't have a lot of swing. On the coax, I have so much swing. I'm actually going to move it in a little more against the friction. Now you can see when I bring it down how far that ball is inside this boss. And again, that's fine because we have a lot of travel on these. So I'm going to bring it down, let it touch the outside of the boss, which is why it's angled like that, so it actually can get on the outside of a diameter now. All right. And I'm just going to swing this around, and you can see because we didn't move off the center of this, we're still within a couple thou of indicator movement. I don't have to indicate this back in, it's exactly the same process. I just wanted to show you how the stylus for the OD attachments or OD styluses work. But again, pretty much the same feature. And if I wanted to get to this big outside diameter here, I would just use the extremely long version of this to go around the outside. Again, works very nice. And even the long internal stylus, if I have a, let's say this bore was down 6 inches, and I wanted to indicate in a bore that had a step in it, way down into a cylinder or something like that, I can put the long stylus on it and then use the coax ID version for that. And again, coaxes, love them. They're extremely user-friendly. And the other nice thing is when you move the bezel, because it's hard mounted to the actual holder or the chuck that you're using, you move it, it doesn't affect the gauge like it does on the other style indicators. So what I'm going to do now is I'm going to put a regular indicator in, and I'm going to show you how I indicate in a hole using a regular indicator. Instead of using the big hole, I'm using one of the smaller holes. And just a little trick that I use, other people might not need to do it. I do it because I think it saves me time. So let's go to, I'm going to switch out the indicator, and then we're going to go to one of these smaller holes here and then indicate one of those in. Okay guys, so what we're going to do now is I'm just going to use this vertical indicator on the Edge Technologies arm. Again, like I said in the other video, I like this arm. Again, it looks really nice, but because of these individual friction screws here, you can tighten up these joints to the feel that you like when you're making your adjustments on your gauge. Some of the other arms don't have such nice feature or such nice resolution and building up the friction at those joints. So this works out really nice. I really like this. But I'm going to show you the difference between using this vertical style indicator and then the horizontal one and what the differences are. So we're going to indicate in one of these holes. This is like a 420 thousandths hole or something like that. What I do personally is, because again these don't have a lot of travel tied to them like the coaxes do, I like to get as close to the center hole or the center of these diameters that I possibly can before I actually start indicating, just to save me some headache. Some of the guys I work with in the model shop at some of the other companies, they're extremely quick at indicating in. They don't need to do this. For me, I'm not that quick at it, so this just helps me out, saves me a lot of aggravation. So what I'll usually do is I'll find out what the hole size is, and then I'll find a pin, a gauge pin, that's probably like maybe 20, 30 thousandths smaller than that. And then I'll put that in a drill chuck, bring that down, and then put it inside the hole until I feel it go in the hole. And then I know I'm within 20 thousandths, 15, 20 thousandths of center, and I know that's within the realm of the travel of my indicator. So what I mean by that is I have a drill chuck in here right now. So I'm just going to put it in the drill chuck, and I'm going to bring this down. And that's all I'm going to do is I'm just going to bring it close to the hole until I get that pin to go in. Oh, that's pretty good. Got it the first time. So that pin's going in that hole, and that pin's about like 25,000, 20,000 smaller than the actual hole itself. So I know I'm pretty close right now. So I would zero out my controller at that point. So I have a relative zero position. And then now I'll go in and I'll put my indicator in. And then the other thing about the indicator, when it comes to these vertical styles, let me just move this head up a little bit. One thing about these indicators, and we'll see if you can see that here. You can see if I can zoom up a little bit. Let me arrange this a little here. One thing that I do, and again, it's just a personal preference, is I try to get the ball of this, the end of my indicator tip, when I rotate the head around, I try to get it so it actually looks like the indicator ball is actually moving around a center line and it's not ripping around a big diameter like that is. I try to move it in until I get it where it looks like it's rotating around its own little center point. And again, the reason I do that is that when I drop it into the hole and move it out, it's just a lot easier to get set up, and I don't use as much of the swing of my indicator. So that looks pretty good there. I mean, it looks like it's rotating around its own little center point there. So I'm going to bring it into the hole now. I'm going to put the gauge your way there. Okay, so let's bring it down into the hole. You know, what I'm going to do is I'm just going to move it out until I get some preload on it. Okay, so, and then you can see as I start trying to move the bezel, that gauge is moving all over the place. So I'll hold it, and then I'll just turn the dial, get it close to 0. Alright, and again, I'm just chasing 0 at this point. So as you can see, when I rotate this around, alright, the dial is going to start moving out of your view and out of my view as well as we go around this. And this is where the mirror comes in, and I know the last time I tried to do this in the Haas, that's all you saw was my face. You can actually see the gauge. But as we move around this, you can see that because I pinned it, the actual movement off of 0 is not that much. And that's because I got it pretty close already with the pin itself. So right now, if I use the same process that I used on the coax, where I take this position here, I 0 it, and then I go 180 degrees out, and you're not going to be able to see that, I know, and I look for 0 again, and then I adjust to bring it back half to 0. So right there I'm 0, and I am 0 there as well. And I would do the same thing on the Y. So again, you know, use the mirror like this, find my 0 right there, rotate it around 180 degrees, and again, I don't know if you can see that, but I'm about 5 thousandths, 4 thousandths off, so I'm going to go half of that distance, 0 that back out, and then I'm going to go around again and look at my so right there we're a couple thou out. I'm going to call that 0 just for this video. Trying to show you on the mirror there. So as I rotate this indicator around now, I should get very little movement off of 0. So I'm 0, just about 0 there. You can't see that. That's about 0. And a couple thou off of 0. Okay, so again, so that hole is indicated in, and by using the pin, you can't see the controller up here. So when I pin that, my X position now is 1 thou and my Y position is 5 thou. So I was that close by just driving the pin in there first and then doing my indication. I only had to adjust these a half thou in the X and 2.5 thou in the Y. So that's a really good way of again, for me, a good way of actually getting the hole close. So I'm going to switch the indicator out to the horizontal one, horizontal indicator, and you're going to see the difference from that and the vertical. Okay guys, so we have the vertical, or the horizontal indicator in here now, and again, you're going to see the difference. So the methodology is still the same. I still adjust this head to get this tip, and you can see how easy this moves. And this screw is pretty tight right now, and it still moves quite a bit. I'm still using the same method where I'm going to take this and I'm going to try to get the ball to spin around its own 0 or its own center line as much as I can before I put it in the hole. All right. Again, this hole is pretty much already indicated in, but it's more to show you the difference, and you'll be able to see some of the difference, not all of it. But so I'm going to drop this into the hole now. Let's move this way, and I'm going to bring this out now until I get some load on the indicator. Okay, so there's some load on the indicator. Now the nice part is that as I start to rotate this around, even though you're not going to be able to see it the whole time, I can see that dial as it's going around. Without a mirror, I can see it here. If I look this way, I can see it. So I don't need a mirror when I'm using this horizontal style indicator to actually see the indication. And again, that just works out really nicely. So again, we have a few of these in the shop. Some people don't like to use them. I don't know. To me, I'll use anything that indicates a hole in, whatever's available. If someone else already has this on the machine and they're using it, I'll use a horizontal, I'll use a vertical, I'll use an edge finder, whatever it takes. But again, this just shows you the difference between the horizontal or the vertical and the horizontal style indicating tip that don't have a lot of travel on their needles. So again, you still want to get it somewhat close to the hole center before you actually use this. The coax, you have a lot more flexibility. So the last one I'm going to show you is the 3D, and again, there's nothing really rocket science about that. It actually is just a really simple way of setting up anything. So let me just throw that in, and that'll pretty much be it for this video. Okay, so we have the 3D indicator in there. Again, 3D because you can get both X and Y, and again, you can actually push up on this needle as well and get displacement in the Z for setting up your work offsets and your tool height offsets using this indicator. I'm just going to show it for X and Y. So again, if I get it close to the center of a hole, here I eyeballed it, and it's already centered, we know from indicating. So this is just to show the principle. But this is how easy it is. So basically, I'm going to start moving it in the Y. So I'm going to go here, and I'm going to say, I would edge find, or not edge find, but I would actually, once I got zero readout on the indicator, I would zero out my controller here. So I'm just going to do that. And that was 0.19995. And I'm going to go the other way, and I'm going to go to a zero position there, and I get 3975 in the negative direction, 0.3975. So if I split the 3975 dimension, that will actually be the center of my hole, because basically I moved this to a zero position on the edge, basically put the center of my spindle right at the edge of that hole, moved it over, zeroed it out, then moved it over in the negative direction, and then found my edge again of that hole. Using this zero indication here, half of that distance is going to be the center of my hole. Okay, and once I have that, I can then go into my X position. I'm not changing the dial, I'm not doing anything, I'm not rotating. I'm just going to go until in the X position, get zero or close to it, zero out my controller, and then go the other direction until I zero out here again, right about there, let's say, and that's 3975. So half of that distance is the center of my hole. So I picked it up in the X and the Y without doing any rotation, any indication, anything at all. And I could do that with the big diameter, small diameters, inside bores. As far as I can get this needle down, or this indicator tip down in a hole, I can go that far. There are different style indicator tips for these as well. So there's a lot of different functionality built into these. Again, I just wanted to show it because again, it's such an easy way to indicate and find edges and centers of holes without doing a lot of math and a lot of rotating around and trying to figure out good positions to put the indicators in. So those are really the three methods I wanted to show: the coax, the two standard style indicator tips, and then the 3D indicator for finding edges and finding hole centers. So that's pretty much it for this series. Unless someone has any questions or they want to see something else or a different way of finding the location of a complicated feature, shoot me an email, and then we'll try to figure out a way to do it. But until the next video, which hopefully will be a project, I will see you then. Cheers.